So today let us start with the class. In this class today we are discussing about measurement using multimeter and digital voltmeter. So initially to discuss about use of multimeter for resistance measurement. Previous class we discussed how multimeter can be used for DC voltage measurement and as an ammeter as well as measurement of AC voltage. So now we are discussing about resistance measurement, how multimeter can be used for the resistance measurement. You are looking at the diagram. This diagram, whatever it shows, it's an ohmmeter circuit for R by 1 range. This figure shows ohmmeter section of multimeter for a scale multiplication of 1. Before any measurement is made, the measurement is short circuited and zero adjust control is varied until the meter reads zero resistance. That is, it shows full scale current. Now the circuit takes the form of a variation of the shunt type ohmmeter. Scale multiplications of 100 and 10,000 can also be used for measuring high resistances. Voltages are applied to the circuit with the help of battery. So coming to discuss about advantages and disadvantages of multimeter. The advantages of an electronic multimeter are the input impedance is high. Secondly, the frequency range is high. Next advantage is the circuit is simple. And next advantage is the cost is less. So next is the construction is rugged. And last advantage is it is less suffered from electric noise. Like that we have disadvantages also. The disadvantages of an electronic multimeter are the accuracy is less. The next disadvantage is the resolution is poor. The next is disadvantage is it is difficult to interface the output with the external devices. Next, not compact in size. Finally, the reliability and repeatability are poor. These are the few advantages and disadvantages of electronic multimeter. So next, coming to digital voltmeters. Students, the digital voltmeters, generally referred as DVM, convert the analog signals into digital and display the voltages to be measured as discrete numericals instead of pointer deflection on the digital displays. Such voltmeters can be used to measure AC and DC voltages and also to measure the quantities like pressure, temperature, stress, etc. using proper transducer and signal conditioning circuit. The transducer converts the quantity into the proportional voltage signal and signal conditioning circuit brings the signal into the proper limits which can be easily measured by the digital voltmeter. The output voltage is displayed on the digital display on the front panel. Such a digital output reduces the human reading and interpolation errors and parallax errors. The DVMs have various features and the advantages over the conventional analog voltmeters having pointer deflection on the continuous scale. So what are the advantages of digital voltmeters and what are the disadvantages of digital voltmeters? We will see that. So the basic, first, before getting to advantages and disadvantages, to know about what are the performance parameters of digital voltmeters, we will see. The various performance parameters of DVMs we can discuss one by one. First one is number of measurement ranges. The basic range of any DVM is either 1 volt or 10 volt. With the help of attenuator at the input, the range can be extended from few microvolts to kilovolts. Secondly, number of digits in readout is the next performance parameter. Here, the number of digits of DVMs vary from 3 to 6. More the number of digits, more is the resolution. Thirdly, the accuracy is the next performance parameter. Here, the accuracy depends on resolution and resolution or number of digits. Hence, more number of digit means more accuracy. The accuracy is as high output plus that is as high as up to it can go plus or minus 0.005% of the reading. Next performance parameter is speed of the reading. In the digital voltmeters, it is necessary to convert analog signal into digital signal. The various techniques are used to achieve this conversion. The circuits which are used to achieve such conversion are called digitizing circuits and the process is called digitizing. The time required for this conversion is called digitizing period. The maximum speed of reading and the digitizing period are interrelated. The instrument user must wait till a stable reading is obtained, as it is possible to follow the visual readout at high reading speeds. So next performance parameter is normal mode noise rejection. So here, this is usually obtained through the input filtering or by use of integration techniques. The noise present at the input, if passed to the analog to digital converting circuit, then it can produce the error, especially when meter is used for low voltage measurement. Hence, noise is required to be filtered. The next performance parameter is common mode noise rejection. This is usually obtained by guarding. A guard is a sheet metal box surrounding the circuitry. A terminal at the front panel makes the box available to the circuit under measurement. Next performance parameter is digital output of several types. The digital readout of the instrument may be 4-line BCD, single line serial output, etc. Thus, the type of digital output also determines the variety of the digital voltmeter. Next performance parameter is input impedance. The input impedance of DVM must be as high as possible, which reduces the loading effects. Typically, it is of the order of 10 mega ohms. So that completes about the digital parameter performance parameters.